Download this code from codegive.com, link in the description below. OK, let's dive into the fascinating and critical world of business logic vulnerabilities. This guide will provide a comprehensive overview, covering what they are, how they arise, common types, detection techniques, and prevention strategies, all backed by illustrative code examples. What are business logic vulnerabilities? Unlike traditional technical vulnerabilities like SQL injection or cross-site scripting, XSS, business logic vulnerabilities arise from flaws in the design and implementation of an application's rules and processes. These rules define how the application should behave under various circumstances. When these rules are poorly designed or implemented incorrectly, attackers can manipulate the application to achieve unintended and often malicious outcomes. Essentially, business logic vulnerabilities are about exploiting the intended functionality of an application in an unintended way. The code itself might not have any syntactic or traditional security flaws, but the way the application handles business rules can be flawed. Why are they important? Difficult to detect. Business logic flaws are often subtle and complex, making them harder to find with automated scanners and penetration testing techniques primarily focused on traditional technical vulnerabilities. Significant impact. Exploiting these vulnerabilities can lead to serious consequences, including financial loss, data breaches, fraud, reputational damage, and regulatory penalties. Application specific. Each application has unique business logic, meaning there is no one-size-fits-all solution. Identifying and mitigating these vulnerabilities requires a deep understanding of the application's purpose and workflows. Underestimated threat. They're often overlooked during security reviews, as development teams prioritize protecting against more common, easily identified vulnerabilities. Common types of business logic vulnerabilities, with examples. Let's explore some of the most prevalent types of business logic vulnerabilities, complete with code examples to solidify your understanding. 1. Insufficient authorization/access control. Description. Occurs when an application fails to properly restrict access to resources or functionalities based on user roles or permissions. A user might be able to perform actions they shouldn't be allowed to perform, or access data they're not authorized to see. Example, insecure direct object reference, IDOR. Vulnerability. An attacker can change the user_ID in the URL to view the balance of any user, including the administrator. There's no check to ensure the user requesting the balance is actually authorized to view it. Fix. Implement authorization checks. For example, use a user session and verify that the user_ID in the request matches the logged-in user's ID or that the logged-in user has appropriate admin privileges. Explanation of fix. Session management. Implemented a basic login/logout mechanism using Flask session management. This allows tracking of the logged-in user. Important. In a real application, use a more robust authentication system like OAuth or OpenID Connect, and never store passwords in plain text. Use strong hashing algorithms like BCRYPT. *at login_required decorator. This decorator checks if a user is logged in before allowing access to the root. Authorization check. Inside the get_user_balance root, it checks if the logged-in user is an administrator or if the user_ID being requested matches the logged-in user's ID. Only then is access granted. Admin root. Added a separate root to allow admins to check the balance of any user. This root requires the @admin_required decorator. 2. Logic bugs in multi-step processes. Description. Many applications involve multi-step workflows, example ordering a product, Applying for a loan. Bugs can occur if the application doesn't properly track the state of the process or if steps can be bypassed or repeated. Asterisk example, e-commerce discount abuse. Vulnerability asterisk the apply_discount function applies the save 10 discount without any checks. Asterisk eligibility asterisk it doesn't verify if the user is eligible for the discount, example if they're a new customer, or if the discount is still valid. Asterisk usage limits asterisk it doesn't prevent the same discount code from being used multiple times. Exploit asterisk an attacker could repeatedly apply the save 10 discount to the same order, potentially reducing the price to an absurdly low amount or even zero if combined with other discounts. Fix asterisk. Explanation of fix asterisk. Asterisk applied_discounts asterisk a set is used to track which discount codes have already been applied to the cart. Asterisk eligibility check asterisk the is_discount_valid function, a placeholder, simulates checking if the user is eligible for the discount and if the discount is still valid. In a real application, this would involve querying a database or calling an external service. Asterisk usage limit asterisk the code now checks if the discount code has already been applied before applying it again. Asterisk user ID asterisk the cart class now takes a user_ID to track the user associated with the cart. This is important for checking eligibility for discounts and preventing abuse across multiple accounts. 3 Data validation issues asterisk. Asterisk description asterisk insufficient or improper validation of user input can lead to unexpected behavior and security vulnerabilities. This includes not only checking for format and data type but also validating against business rules. Asterisk example, insecure quantity input. Vulnerability asterisk. Asterisk negative quantities asterisk an attacker could enter a negative quantity, potentially leading to a refund or credit being applied to their account. Asterisk excessively large quantities asterisk an attacker could specify a very large quantity, potentially causing an integer overflow or other unexpected errors in the application. It could also be used in a denial of service (DOS) attack by overwhelming the application with large numbers. Fix asterisk. Explanation of fix asterisk. Asterisk type validation asterisk the code now explicitly converts the quantity to an integer using int. It includes a try except block to handle cases where the input is not a valid integer. Asterisk range validation asterisk the code checks if the quantity is within a valid range, greater than 0 and less than or equal to a maximum value. The maximum value is determined based on business requirements. 4 Race conditions asterisk. Asterisk description asterisk race conditions occur when multiple threads or processes access and modify shared resources concurrently without proper synchronization. This can lead to unpredictable and often incorrect results. Asterisk example, limited resource allocation. Explanation. Asterisk threading.lock, a lock object is used to synchronize access to the available_seats variable. The with lock statement acquires the lock before accessing available_seats and releases it automatically when the block is finished. This ensures that only one thread can access and modify available_seats at a time, preventing race conditions. Asterisk time.sleep, 0.1, a short delay is introduced to simulate the time it takes to process the booking request. This makes the race condition more likely to occur if the lock is not used. Asterisk global available_seats, declares that available_seats is a global variable so it can be modified within the function. Asterisk threads.append, thread, and thread.start, creates and starts the threads. Asterisk thread.join, waits for all threads to finish before the main program exits. Vulnerability, without the lock. Without the with lock block, multiple threads might read the value of available _ seats simultaneously before any of them have a chance to decrement it. This could lead to more seats being booked than actually available. Fix, with the lock. The with lock statement ensures that only one thread can access and modify available _ seats at a time. This prevents the race condition and ensures that the correct number of seats is booked. The output will show that only 10 users are able to book a seat, and the remaining 2 will be rejected. Important note: race conditions can be extremely difficult to debug and reproduce, as they depend on the precise timing of events. Testing for them requires careful planning and specialized tools. 5. Price manipulation description occurs when an attacker can manipulate the price of goods or services, typically in e-commerce or financial applications. Example: insecure price override. Vulnerability the calculate _price function allows a price override parameter that completely overwrites the calculated price. There's no validation to ensure the price override is reasonable or within acceptable limits. Exploit an attacker could provide a very low price override value, example 0.01, to purchase a product for almost nothing. Fix explanation of fix input validation the code now checks the price override value for the following. It must be a number. It must be non-negative. It cannot exceed the original price. It must not exceed a maximum allowed discount, example 50% in this example. This protects against excessively low price overrides. 6. Information disclosure description sensitive information is unintentionally exposed to unauthorized users. This can happen through error messages, debugging information, or insecure API endpoints. Example: verbose error messages. Vulnerability in the except block, the application returns a detailed error message including the full traceback. This traceback could reveal internal file paths, database connection strings, library versions, sensitive data. Exploit an attacker can trigger an error, example by providing an invalid user ID or manipulating the request in some way, to obtain this information and use it to further compromise the system. Fix explanation of fix logging the code now logs the full error details, including the traceback, using the logging module. This allows developers to investigate the error without exposing sensitive information to the user. Generic error message the application returns a generic error message to the user, such as an unexpected error occurred. This avoids revealing any internal details about the error. Disable debug the application enables the debug only on development environment. Detection techniques 1. Manual code review carefully review the code, paying close attention to business logic implementations, especially authorization checks, multi-step processes, and data validation routines. This requires a deep understanding of the application's functionality. 2. Threat modeling identify potential attack vectors by analyzing the application's architecture, workflows, and data flows. Consider how an attacker might attempt to manipulate the application to achieve unintended outcomes. 3. Fuzzing use fuzzing tools to automatically test the application with a wide range of inputs, including unexpected values and edge cases. This can help uncover data validation issues and unexpected behavior. 4. Penetration testing hire experienced penetration testers who specialize in business logic vulnerabilities. they will attempt to exploit the application's business rules to gain unauthorized access, manipulate data, or cause other harm. 5. Static analysis * employs static analysis tools to identify potential vulnerabilities in the source code. These tools can help detect issues such as missing authorization checks, insecure data validation, and race conditions. However, they may not be as effective at detecting complex business logic flaws as manual code review and penetration testing. 6. Runtime monitoring * monitor the application's behavior at runtime to detect suspicious activity, such as unusual input values, unexpected state transitions, or unauthorized access attempts. This can help identify and respond to attacks in real time. Prevention strategies * One principle of least privilege * grant users only the minimum level of access required to perform their tasks. 2. Input validation * thoroughly validate all user inputs to prevent injection attacks, data manipulation, and unexpected behavior. 3. Authorization checks * implement robust authorization checks at every level of the application to ensure that users can only access the resources and functionalities they are authorized to use. 4. State management * carefully manage the state of multi-step processes to prevent users from bypassing steps or repeating them multiple times. Use secure session management and transaction management techniques. 5. Error handling * implement proper error handling to prevent sensitive information from being disclosed in error messages. Log errors securely and provide generic error messages to users. 6. Secure coding practices * follow secure coding practices to minimize the risk of introducing vulnerabilities. This includes using secure libraries, avoiding hard-coded secrets, and following industry best practices. 7. Regular security assessments * conduct regular security assessments, including code reviews, penetration testing, and vulnerability scanning, to identify and address potential vulnerabilities. 8. Security training * provides security training to developers and other personnel to raise awareness of business logic vulnerabilities and how to prevent them. 9. Automated security testing * use automated security testing tools to detect vulnerabilities during the development process. This can help catch issues early and prevent them from making it into production. 10. Defense in-depth * implement a defense in-depth strategy to provide multiple layers of security. This makes it more difficult for attackers to exploit vulnerabilities and compromise the system. 11. Rate limiting * implement rate limiting to prevent abuse of functionalities. 12. Two-factor authentication, 2FA use 2FA to protect user accounts. 13. Consider using web application firewalls. WAFs can help detect and block malicious requests. Final thoughts * Business logic vulnerabilities can be some of the most challenging and impactful security flaws to address. A strong understanding of the application's business rules, a proactive security approach, and a combination of manual and automated testing techniques are essential for mitigating these risks. Remember that security is an ongoing process, and regular assessments and updates are critical to maintaining a secure application.